All right. Hello, everyone. My name is Nima Kaviani, and today with my colleague Swetha Repakula, we're going to talk to you about how you can deploy your application irrespective of the public blockchain or the private blockchain that you use. So if you have, oops, it jumped in too quickly, I think. There you go. Okay. So if you've been a developer of blockchain applications, you know that the process is actually difficult. You know, I'm sure all of you, this thing actually takes me too quickly through so many slides. Okay. Nope.
No worries.
I think it's just jumping too fast. All right. Sorry. Start over. If you've been a developer of blockchain applications, you know that writing decentralized apps is actually quite difficult. Because what you need to do is that you need to write an application, and if you need to write it in a language like Solidity, you have to learn the language. Once you write the contract, then you have to compile it, then you have to bring up a node or a gateway to deploy your application to the blockchain network. Then once the application is deployed, you have to get the information back from the blockchain network about how to access your contract, and then you have to provide that information to the decentralized applications that you have, whether it's a Web3 or some other sort of application, and only then you're going to be able to use the application. So this entire process is quite cumbersome and requires an in-depth knowledge of writing the code, using the blockchain, connecting it to the network, et cetera, et cetera. So as we were looking into this process, we realized that there are a number of things that we can simplify. So the team that we formed started looking into motivations for making this entire process simpler. What we wanted to do was to make the deployment and development of Web3 applications easier. We wanted to simplify the way blockchain networks are accessed when you actually develop blockchain applications or decentralized applications. We wanted to make it easier to manage the network or the blockchain network that you're using, whether through the gateway or a proxy or a node. We wanted to control the lifecycle of the node that you bring up in order to connect to the network. We wanted to manage the lifecycle of the contract that gets deployed so that you can more easily bring it up, bind it to your application, and then kill it off. We wanted to make it ready for production deployments in a much easier way compared to what it is right now, in the sense that we wanted to abstract away a lot of this underlying knowledge that you had to have about the blockchain network and kind of provide a simpler way of accessing and managing your contract lifecycle and your deployed applications. And we wanted to make sure that the Web3 applications or decentralized applications that you develop remain agnostic to the underlying blockchain network. So if you choose to go from a public blockchain network like Ethereum to a private blockchain network or a permissioned blockchain network like Hyperledger Fabric, you can do it seamlessly with as minimal intervention to your code as possible. So the high-level vision that we had for this project when we started thinking about it is that, as blockchain gains more momentum and it starts being used by organizations, we wanted to make it so that for every organization that chooses to do these peer-to-peer trustless transactions, they are able to actually utilize it in their production environment in a much easier way, and they can actually benefit from the offerings of cloud to deploy their decentralized applications for the purpose of scalability and availability. So what we did was that we started looking into ways to do it in the cloud. And one of the interesting things is that the team that we have when we had when we started working on this project, we are all coming from cloud development backgrounds. All of us are core contributors to cloud platforms. Swetha and I have contributed to Cloud Foundry, and we've also looked into Kubernetes and other stuff. So we know quite a bit about what it takes to write applications for the cloud. And if you're familiar with the concept of 12-factor web applications in the cloud, you know that there are like 12 principles that every application that gets deployed to cloud platforms need to follow for it to be scalable and highly available. If you're not familiar with these 12 concepts, I highly recommend that you actually go and look into them. But the important thing is that the application needs to be configurable, it needs to be auditable, you have to be able to collect logs and monitoring information, you need to be able to bind the state as type of a service to the application. And then when you provide all of this to a two-factor application, then you're going to be able to seamlessly, scale the application and make it highly available. One of the important aspects about these 12 factors is the backing services. And so if you deploy an application in the cloud, what you want to do is that you want to manage the state that the application requires through some services. And these services can be database services, file storage services, code repository services, et cetera, et cetera. So we came to this problem that I mentioned initially about trying to make decentralized application more easily developable with this knowledge that we had from developing 12-factor web applications. And what we noticed is that decentralized apps are essentially not very different from 12-factor web applications. The difference is that, usually the state that these applications have are kept in the blockchain, right? So one thing that we realized is that we can provide blockchain as a backing data store to the application. And that's the idea that basically resulted in, kicking off this project. So we thought that we can provide a permissioned blockchain or a public blockchain as the backing service to a decentralized web app. And that's how we formed the idea of developing a service broker. So the idea for the service broker is that the service broker is a piece of software that manages the services that are provided to your application. And in the case of a decentralized app, and this can be the blockchain service that is offered to your application. So I am going to quickly go over the architecture that we had for the design of the broker. So on the left end, you see that you have a cloud platform. This cloud platform can be anything like Cloud Foundry, it can be Kubernetes, it can be Heroku, or basically any platform that can run your decentralized application. In the middle, you have the broker. And the idea for the broker is that it provides you two levels of abstraction. One for managing containers, and the other one is for managing the blockchain network. So the broker basically does two things. It provisions services, and then it binds services to the applications. So let's see what happens when you try to provision a service with the broker. When the provision happens, the platform sends a request to the broker to bring up access to the blockchain network. Now the broker, with its container manager, looks into the type of network that your application wants to connect to. If it's a public blockchain network like Ethereum, it brings up a get node. And then the get node gets connected to the rest of the network, the Ethereum network. And the information, the address for that node, then is provided back to the platform that the application runs. If it's a Hyperledger Fabric, for example, then what the broker brings up is a proxy or a gateway to the network, which provides authentication and authorization for the users. And again, the information gets relayed back to the platform. The next step is to bind the service with a contract. So what happens is that the platform sends a contract information to the broker with the information about which node the contract needs to be deployed to. And at that point, the blockchain deployer takes the contract, goes to the node, whether it's the get node or whether it's the proxy, deploys the contract through the node into the blockchain network, gets the information for the deployed contract back from the network, which is like the contract address and some other information that it requires to connect to the deployed contract, and provides all of that information back to the application. And now you have an application that has the contract information and the IP address of the node that it can talk to, and the port where the node responds on. And with all of that information, then you can easily start interacting with your application. The decentralized app can start communicating with the node and then start writing and reading from the blockchain network or to the blockchain network. So the essential parts here are the container manager interface and the blockchain deployer interface that we've kind of used to abstract away the complexities of where you run your node and what type of node you run, and also what type of blockchain you want to deploy your contract to. So with that, I'm going to pass it to my colleague Swetha, who's going to talk a little bit more about the details of how this whole thing works and shows you a demo.
So some of the things that when we started doing this work, we knew right away that we're not going to only support one network. We want to make sure our thing is scalable and we're able to add other blockchain networks as, some become more popular or if there are different reasons. So obviously we were talking about permissioned networks as well as public networks. So that's one big thing. That's actually the second section there. That's the blockchain deployer interface. And the idea is we should be able to deploy either blockchain nodes when it's a public network and you can run full nodes, or it could be access points or gateways into a network when it's a permission system like Fabric where not everyone's allowed to run a node. So we wanted to make sure that piece is flexible. The other piece that we wanted to be flexible on is how are these nodes being deployed? So our initial way we do this is we're actually create a VM. We expect that you create this broker and is running in a VM, and we use Docker to kind of manage the nodes, and they bring up some of these images. Now, for a public network, something like Ethereum, get node is a very standard image. It's very easy to just kind of run that and maybe pass in a few different arguments if you want to connect to testnet, mainnet, maybe you want to run it in dev mode. It's all in the end, it's the same Docker image. So we thought, okay, Docker is one. We're using the concepts of containers and stuff and trying to apply it to some of these blockchain nodes. The other thing that we thought is with the popularity of Kubernetes, we want to be able to scale up because on a VM, right, you're limited to the resources that one VM has. Versus a Kubernetes clusters, you can add clusters, you can expand it, you can add more pods to it. So we've also made sure that the nodes and these access points that we're deploying, we're going to also make it available using a Kubernetes thing. So let's kind of go into some of those container manager implementations. So as I said, currently we support Docker and Kubernetes. Let's dive a little bit into Docker quickly. So the first thing is we use something called the Docker BOSH release. So if you're familiar with Cloud Foundry and the technologies that are used there, BOSH is just a way to deploy software and run it in VMs. BOSH kind of makes it a nice, simple way, so that way you write the software once, but you can deploy it, whether it's to the IBM Cloud or whether it's to AWS, GCP. It kind of makes that interface a little bit easier. So that was our first attempt at how we wanted to do this. This Docker BOSH release, it works really well with the Cloud Foundry platform because Cloud Foundry itself, its way of being deployed is also a BOSH release. And the idea is every service that you create, if you're familiar with the Open Service Broker API, we call these services when you ask for something. These are actually going to each correspond to a specific Docker container. So the idea is when one person asks for a node, they're not sharing a node with somebody else. It's private, it's confident, the data is separated between the two nodes, as much as can be on a blockchain network. The next thing is the Kubernetes implementation. We're going to do a very similar kind of approach, except that the broker itself is going to be running in Kubernetes. When you start it up, you're going to configure it with the cluster information, so that way anytime you create a new service, the broker is going to create a new pod, and that new pod will be running whether it's your Geth node or if it's your Fab3 proxy, depending on that. Again, it's up to the services. And what we've made the whole broker architecture really easy is these are all Docker images in the end. We expect that you can add whatever you want as long as it kind of fits some of our interfaces, and if it's able to respond to the API that we've kind of created into these nodes. If it's able to respond, you can add whatever images you want that connect into the network. Currently, the one that we're supporting right now is the Ethereum JSON RPC API, so which is basically what Geth implements. We also have work in Fabric in implementing something we call the Fab3 proxy, which allows people to use Ethereum clients and tools and interact with Ethereum smart contracts on Fabric. So that kind of brings me into the next thing. What is the back-end blockchain network? So the first thing we tried was the public Ethereum network. We found this was an easy thing to kind of start off with for many of the reasons I just said, or I mentioned previously. Geth node is simple. There's only one image, there's only one network, or there's only a few different networks out there that people want to connect to. And it's very easy to make assumptions. So we can say, hey, this person wants to connect to testnet, we know how to do that. we know how to connect to mainnet, and it's kind of all. Currently, we're supporting only dev nodes, but the next step is to take our dev nodes and connect them into a public network. And the problems there, or the type of decisions that we're actually looking into, is how do we make sure we're not copying tons and tons of ledger information, because in the end, these nodes are all kind of being connected to this broker. So we want to simplify some of that process. Now, when we come into a permissioned network, there are a lot of decisions that we kind of had to make. So the first thing is, as a permission network, permission can mean many different things, whether it's about the user being allowed to submit a transaction, to whether the user is allowed to submit a node, how much information does the user have to be able to connect to a network, who's in control. So these are all like a lot of open-ended questions, and it becomes like a use case kind of a situation. So what we decided is that we're going to put a little bit of a burden on the operator of this broker. If they're going to support and they're going to have permission network on there, they need to have some kind of information about how do you connect to this network, where is it located, what is the topology of it. And we expect them to actually create the Docker image that they want their users to be able to deploy. In this case, these are some of the things that I think are important to consider when you're creating that Docker image. One is the network information. So what are the peers? What are the I'm using Fabric terminology, but what are the nodes that this proxy or this node, or what other nodes should the Docker image or the container be allowed to talk to? User credentials, how are we going to get those credentials in there? Currently, we've gone with the approach that if you are creating this broker, you already have access to this network. You're probably managing that a node in that permission network. So you probably can bake in some kind of credential system into the container itself. This, depending on how the network works, you can change it. For example, currently we have all the credentials and stored into our Fabric container that we're using, but in the future we want to convert to using the certificate authority that Fabric has, Fabric CA, to do some kind of user creation as well as at least some kind of a basic auth when the user deploys their service. And I'll show you that in the demo, what I mean by that. As I said, Docker images, we're going to put the burden on the operators to create them. They have to offer it. They get to decide what is the information that a user needs to provide when they create the service. Am I expecting them to just give me a username and password? Am I expecting them to just say, hey, I want to be part of organization 1. This is the channel that I'm creating. Again, it's kind of up to the operator, and I'll show you an example of what we think would be a reasonable approach to this. And then the last thing is the deployer interfaces. So now we've mentioned deployer interfaces in 2 ways here. One is how is the actual blockchain network node proxy being deployed? That's one thing. But the other thing is also how are smart contracts deployed on these permission networks or on these public networks? So we've kind of, I wouldn't say we cheated, but we've kind of used some of the technologies and the integrations that are occurring to make this process a little bit easier for us right now. We have an Ethereum deployer, which basically uses the Ethereum JSON RPC API, and it expects that whatever proxy node or that it's communicating to implements that. So it makes it a little bit easier so we can use Ethereum tools like Web3.js to deploy smart contracts, get contract information and the schema all out, and it's all kind of one basic interface that's happening. We want to, in the future, though, expand this and support some of the other languages that are out there. So for example, Hyperledger Fabric has Go and Node smart contracts. It would be nice if we give them the ability to be able to deploy those using our similar process. So let me quickly go over what I want to show you guys in a demo. We have a broker that's deployed on a Bosch Lite. Bosch Lite is basically a mini VM that's running on my machine currently, and the broker is deployed on there. We also have a platform, a Cloud Foundry platform running on the same VM. What we're going to do is we're going to create an Ethereum and a Fabric service. So in the Ethereum, that means we're going to start up a Geth node. We're going to do it in dev. In Fabric, what it means is we're going to start up a Fab3 proxy. If you're familiar, or this is a slightly new feature in Fabric, there is an EVM chain code that's been created, and there's a Fab3 proxy that uses the Ethereum JSON RPC API, so Ethereum clients can talk directly to the chain code that's been installed in Fabric. We're going to push a voting app, which is basically a decentralized application that we've created. It is going to use the Web3.js as its way of communicating to a network. And then what we're going to be able to do is we're going to provision it, we're going to bind it to the Ethereum service, we're going to show you that the app is running, and then we're going to switch the blockchain network behind the scenes, and we're going to show you how the application is still working, and all we've done is just switch which network it's talking to. And then with that, let me try. Okay, so let me know if you cannot see that, just raise or say it's too small. So we're going to start off with showing you the Cloud Foundry marketplace. This is basically, if you're familiar with the PaaS, this is basically saying all the services that are created. As you can see, we have an Ethereum service, and there's a plan that says get dev. There's a Fabric service Fab3, and there's Fab3 org 1 and Fab3 org 2. So earlier I was mentioning that there are some decisions that the operator is going to have to make when they create their Docker images. So in this case, I'm going to say that the difference is going to be they've created an image for organization 1, and they've created an image for org 2, and typically you would think that both of them would not be available, but just to kind of show how you could split this up is why we have both of these plans available. On the right, what we have here is the actual broker, the broker that's running in a VM. I have a Docker PS. This is using the Docker Container Manager for the moment, so we're going to be able to track what containers happen. So as I do some things, you should be able to see some changes happening over here. So the first thing I want to do is I'm going to show you my application. I've already deployed it to kind of speed up the upload times and everything and not worry about the internet too much. But it's stopped right now. It's not connected. To show you what's the environment that the app is running in. You can see there's not much information. If you're familiar with the PaaS, this is all basic information about, what are the resources it has, what are the routes to it. I wouldn't worry too much about this, but this is just to show you nothing is connected to the app right now. With that, I'm going to create a service. And as this happens, you should see a Docker image will show up on the right. Okay, there you go. So as you can see here, this is a Docker image that we've kind of just played with. It's an etdev. There's nothing special about it. It's a get node that's running with the dev flag on it. What you can see here is the ports that are open on this. The one that, if you're familiar with Ethereum development, is the 8545 port, which is this one. That's the one that they expect DApps or clients to talk to the node. So from there, we want to now deploy a smart contract. That was kind of one of the pieces. The idea is we want to separate the web app development or the DApp development from the smart contract deployment and the blockchain node management. So all we have to do in this case is bind the service. I'm going to bind it to eth, and we provide here some information. So all we have to do is give it the contract URL. So the expectation is this contract is a Solidity contract, and it's available somewhere on the internet. I have a simple polling app that our DApp uses. It's, again, very simple. There's two options. You can vote A or you can vote B. And all I'm going to do is I'm going to take this URL, pass it in. Before I do that, I'm going to show you guys some, so we can watch some of the logs here. And then as this happens, we should see some of the instructions going through. Cool, and you can see here we've sealed, you can see that it's mine new blocks. And then there's also a contract creation, which is the contract that we have given. And you can actually even see the contract address right there. So what I'm going to also show you here before I show you the application is I'm going to show you the environment that it has. And previously, all of this information wasn't there, but there's this new object that's been there called the VCAP services. Each platform is different, so it might not show up like this everywhere, but this is information that the broker has returned to the platform, and it's up to the platform how to show that information to the user in the end. Here we have something with an ETH, that's the key of the service. And if you can see, this is all that information that if we did the Docker PS, it's all that port information. You have the addresses of where this container is located. And then if this is all kind of information that an Ethereum DApp needs, it's the ABI, which is basically the schema of the smart contract, so it's able to communicate. You have a user account address here, and I can see that the contract address did not show up. So let me run this again. And then as we do this, this is not intentionally part of the demo, but you can see that the container goes away, just to show you that we're starting afresh. And as you can see, we have a new container that's running. From here, I'm going to bind the service again. It's going to do the same thing. I'm not going to show you the logs because it's going to look exactly the same. But we'll give it a second. Let's see if this time this worked. And you can see now we do have a contract address. Previously that was missing, and it is. So with that, there's one more thing. So this DApp, because of how Cloud Foundry provides the information to the DApp, it uses this key called ETH, which is the service name that we used when we created the service. So when I switch over to a Fabric or something else, it's going to have a different service name. For ease of being able to switch the application, we also, the application that we have requires one more environment variable to be set, which is the service name. And all I'm going to do here is say that it's ETH, that matches that key. And then if I do, one more. And then if I do, we should see an addition of this being in the environment. And with that, we should be able to start the vote. By the way, this DApp is written using Node.js, and I think I mentioned before, it's using the Web3 JS library to be able to communicate. Okay, so once this happens, let me do Docker PS again. So with this, then I'm going to just go to this application. It's a very simple, kind of fun little question. Do you prefer dogs or cats? I'm an avid dog lover, so the only acceptable answer is this. As I submit this, we're going to see some logs that are kind of piling up here. You can see a new block is being minted. And then with that, this is our results page. It's just pulling. So the dogs and cats actually correspond to the poll, vote A, vote B part of the contract. So now with that, let's move on and let's try to deploy this using to a Fabric network. So we have a Fabric network that's running in the IBM Kubernetes service. I'm just going to quickly show you what we have here. Okay, while that loads, we'll get some of the other instructions. So just to remind us what services we have, we're going to create one more service, Fab3. Let's say we're part of org 1. I'm going to call it my Fab3. And then here, before we didn't have to provide any information at the provision time. Here we do. Here we're going to expect the user ID. We already have a user 1. And then we need a channel so it knows which channel it's going to be running these transactions on. So while this happens, go back to the Docker watch so you guys can watch this. And now you can see there is a new container. This is a different image. It's a Fab3 org 1 versus the eth-dev. If I go back here, we can see this is the mini blockchain network that we've deployed. We have 2 organizations and a peer in each, which is basically a node in Hyperledger Fabric. And then we have an orderer, which is the component that produces the blocks. What I have up here is the orderer logs, so that way we can see when a new block is being created. Similarly, I'm going to do PS. I'm going to get this, so that way we can watch these logs. So that is our Fab3 proxy that's running. And then I'm going to do a bind service. Now, if you look, the only thing I have to change here is the name of the service that I've created. Everything else is the same at this point. And then as this occurs, we should see both logs here, and we'll start getting logs over here. So you can see estimate gas. The logging on Fab3 is not the same as get. It's not going to be able to tell you when a block has been mined because it's an access point. It's not actually a node. And then here you can see we've developed more logs because a block has been created. I'm not going to go through these logs, but just to kind of show you what's happening. And then with that, we're going to stop the voting app temporarily so we can kind of switch it. The other thing we need to do to tell it to move is change the service name again. Oh, yes. Let me quickly, before I do that, I'm going to show you guys, we have a new service that's been added into the VCAP services block. So we still have the old Ethereum piece, but now we have a Fab3 piece, and it looks very similar, except here we only have one port mapping. The ABI is exactly the same. If you look, you can see the account address and the contract address are actually different from the Ethereum, which is what you would expect because there are 2 different blockchain networks that we're using. So to make this work, let's do and vote, and I'm going to switch it over to Fab3. And that, I'm going to start the app again. Perfect. Okay, so this is the same page. Remember, it's the same application, so it's the same route. I'm going to just refresh before I go to the part that vote, and you can see we're on a different network because there's no data. And I'm going to restart. As I said, dogs is the only appropriate answer here. So I'm going to go back over here, and you're going to start seeing, again, logs because new blocks are being created. And if we need further proof that we have separated out or we have switched out the backing blockchain network, I'm going to do another watch, Docker PS, and I can CF unbind and I can even delete the service. Okay, with that, we've lost the container, but I can still vote without any errors. Hopefully no errors. And there you go. So I've successfully switched out the blockchain network. We've used the same application, and we can kind of show you that the DApp development now can kind of be separated a little bit from the actual backing blockchain network. Granted, there is a few caveats. Both Fabric and Ethereum support Solidity contracts, which is why this works. But the idea is we want to be able to do kind of things like this and kind of separate the roles that are associated with each of the parts end to end when you're deploying applications on the blockchain network. So let me go back here. So a couple of things that we've already done. This initial broker, so this actually started as a hackathon project, which was written in Ruby. We've rewritten it in Go. We have a dev mode for the Ethereum Geth node available. We are allowing deploying the broker through Kubernetes and Bosch, which we've talked about. And the other cool thing is that the actual nodes can be hosted through Docker or Kubernetes. And then we are supporting permissioned blockchain networks. The one that we're worked on is Hyperledger Fabric, assuming though that you're using the EVM chain code and using the Ethereum kind of client. So that is a caveat to the Hyperledger Fabric support. The next thing we kind of want to look into is actually those nodes, those Geth nodes, we want to connect them into an actual blockchain network. We want to look at support for other permission networks, not just Fabric, and see how that works. So here are some of our resources. So this is a Cloud Foundry extensions project. So here the proposal is the first link. The project repositories, there's the Blockhead, Blockhead Bosch release if you want to deploy using Bosch. And then the last is the app sample application and the smart contract that I used. It's all available on GitHub. And with that, any questions?
It's always a relief when the demo works. Yeah. But as Swetha mentioned, this is completely open source, everything that we presented here. So please, if you are interested, feel free to reach out to us. We are more than happy to extend it to more of community contributions. Questions? All right.
Yeah? Okay. Thank you then.
Thank you.